Hello, everyone. Welcome to ARC4500A's Week 9 lecture. I'm Robert Crawford, and this week we will be going over project delivery methods and team structures, work sharing and cloud collaboration, file versioning and permissions, and efficiencies in production for digital documentation. While this week's topics might seem to have more direct applicability to working in an office setting than to individual studio projects, I ask you to consider how these topics might inform how you design and develop your projects. The constraints of realizing a project need not be thought of as inhibiting creativity. I challenge you to utilize them to help spark creative solutions. Before delving into team structures, I wanted to remind everyone of the large number of potential consultants that might be found on a design team today. Of course, we have architects, structural engineers, MEP, civil, landscape architects, lighting consultants, medical equipment, acousticians, vertical transportation consultants, signage, life safety, door hardware, specification writers, energy modelers, telecom, AV, IT, and security consultants, lab equipment planners, and the list goes on. Even on small tenant improvements that don't touch building structure, one might expect to find an architect and an MEP engineer at the very least. Larger complex projects might have every single one of these and more. These disciplines highlighted here are increasingly common to find working in BIM. It is also worth a reminder that under a general contractor are often a whole host of subcontractors, and during the construction process, those entities are responsible for developing shop drawings. This has incentivized subcontractors and general contractors to utilize BIM. Additionally, many of the key trades are developing even more detailed building information models than the design team to run precise clash detection and avoid issues in the field utilizing software such as Navisworks. On complex phased projects, GCs might even utilize 4D construction sequencing, 5D cost, and 6D project lifecycle information. It is important to understand how those models, both the design teams and the build teams, might relate to one another given different team setups, contracts, and delivery methods. So what are some of the most common project delivery methods? The three dominant contract methods in the United States are design bid build, and construction manager at risk. Design bid build is the traditional means of delivering a construction project where an owner has separate contracts with a general contractor and an architect. Design build is distinctly different from this in that the owner has only one contract with the design build entity, which typically consists of a general contractor and an architect. CM at risk is a project delivery method in which an owner retains a designer to provide design services and retains a CM to provide construction management services for a project throughout the pre-construction and construction phases. The CM is usually a licensed general contractor. Thus, unlike the design bid build approach, the contractor is involved during the design process. In CM at risk, the owner is responsible for the design before a GMP, aka guaranteed maximum price, is set. There are numerous forms of IPD, but the goal of all of them is to facilitate collaboration among the owner and the prime designer and prime contractor. The collaboration takes place from early pre-construction design phases and continues till project completion. PPP, or public-private partnership, is a cooperative arrangement between one or more public entities, typically the owner, and another, typically private sector entity to design, build, finance, and at times operate and maintain a project for a specified period of time on behalf of the owner. We will focus on the first two, design bid build and design build. Design bid build is the traditional means of delivering a construction project. DBB contracts are typically awarded to the lowest qualified bidder. In theory, DBB delivers a low-cost and high-quality project, but as the contractor is removed from the design process, it has a higher potential for constructability issues to be discovered late in the process. The United States can be a rather litigious country to practice architecture in. DBB setup can thus sometimes unintentionally create an adversarial relationship between the contractor and the architect if a contractor has underbid a project, or if an architect has documented something which is not able to be constructed or had incomplete documents at the time of bidding. Design build, by contrast, provides a sole source of responsibility. By and large, this avoids the owner being caught in the middle of any disagreements between the architect and the contractor. Edward Pabor and Richard Pennington explain the pros of DB are that the, quote, contractor is selected based on qualifications, capabilities, experience, and price, thus avoiding some of the pitfalls from contract awards solely based on low price. The design and construction are performed by a single team under one contract. This reduces the owner's risk from diffused responsibility for design and construction. Time can be saved because of ordering materials and site work begin before the total design is complete. There is a close contractual relationship between the design and construction teams, resulting in fewer design orders by the owner that arise from occasional revisions in design by an owner's AE. Overall, design-build contracting has greater potential to save time and reduce cost. They go on to explain that, quote, there are disadvantages as well. The owner may not have the security and comfort of having an AE act as their agent during the project. Even if the owner has an independent AE involved in oversight of the project, the AE does not have as much insight into the design details. As such, with design build, the owner will lose some control of the design process. Design often is managed through owner approval of design documents during performance. While some design elements may be specified, typically the contractor is given flexibility in design. DB is an increasingly common delivery method, especially in California. According to a report from FMI, it is predicted that in terms of construction put in place spending from the 2013 to 2017 period of time to the 2018 to 2021 range, DB's prevalence will increase from 39% to 44%. If you are curious to learn more about the design-build delivery method, you can check out the Design Build Institute's website at dbia.org. Now that we've covered team structures and delivery methods, we will move on to how those entities might collaborate using the full capabilities of BIM. To start with, we will look at what is work sharing. Enabling work sharing involves creating a master project model, known as a central model, from an existing model. The central model stores the current ownership information for all work sets and elements in the project, and acts as the distribution point for all changes made to the model. All users should save their own local copy of the central model, edit locally in this workspace, and then synchronize with Central to publish changes to the central model so that other users can see their work. Enabling work sharing is done by clicking on the Collaborate tab and then on the Collaborate button. Then select the Collaborate within your network and click OK. You will notice the Worksets button is no longer grayed out. There is a little bit more to it than that, so please pause here and watch the related video by clicking on the link in the provided slide deck. Another critical component to understand and take full advantage of work-shared models is worksets. As mentioned in the last video, to be able to modify a workset, a user must check out the workset and make it editable. I suggest paying close attention to the examples of worksets mentioned in the video link and the suggestions about how many worksets should be included for a project, as there is a homework question related to this. Again, please pause here and watch the related video by clicking on the link in the provided slide deck. Being able to utilize work sharing is a large advancement in efficiency from only being able to have one user access a model or a file at a given time, but between different offices that are working on their company's separate servers, sharing those models often becomes a bit of a chore. Team A and Team B have to regularly send their models to one another. These can be large files, and when received, the linked version of that file needs to be updated. It is not too difficult, but with advances in collaboration on the cloud, this can be avoided. Utilizing cloud collaboration, Team A and Team E no longer need to save and send their files, download them, and relink them on a regular basis. If everything is live on the cloud, the teams can simply synchronize and reload each other's live models. If projects are in earlier stages of development or due to other reasons, teams desire to share updates to their models with other team members at key intervals and not have their working models be live, there are options and controls that allow for their models to be published at regular intervals. Autodesk's first version of this cloud collaboration was called C4R, or Collaboration for Revit. This has more recently been replaced by BIM 360 Design. Here is a diagram Autodesk produced to highlight how a variety of users from designers to owners to cost estimators might utilize BIM 360 Design and BIM 360 Docs to allow for an expedient flow of information amongst all parties. To take a step back, just in case you are not familiar with the cloud and wondering what exactly is the cloud, the first thing you need to know is that the cloud exists in the form of disparate data centers, which you access via the internet. It is a collection of networked computer hardware that works together to provide many aspects of computing in the form of online services. So, how does one go about creating a cloud-based Revit model? Please pause here and watch the related tutorial video. Now that you better understand what is involved to create a cloud-based Revit model, let's look at some of the tools available to us in Autodesk BIM 360's web interface. Here we are logged into that website, and we've navigated to the Document Management tab. Under Project Files, you might create folders for different disciplines and model files, as that would make it easy to assign different users or users associated with a specific office different permissions associated with those folders. You will also notice each Revit file has a version number associated with it. If you click on a specific file's version number, you will see the history and at what points in time that file has been modified, and you can also download those various versions in the event you mistakenly deleted something from the model and need to try and recover it. Diving a little deeper into permissions, which is another strength of BIM 360, if we navigate to Project Admin, and we land on the Companies tab, you will notice each company has a certain number of members associated with it. We can globally assign permissions to a company, and then all of those users associated with that company would inherit those minimum permissions, or we can apply permissions on an individual basis. We don't need to go much deeper into the weeds here, but it is important to understand that you might provide certain companies or individuals editing permissions and others only viewing permissions. The Design Collaboration tab also allows us to visualize information such as sheet issuances and which party issued what when, which can be another helpful way for those managing projects on both the builder side and the design team side. Previous lectures have already touched upon the general efficiencies of utilizing BIM over earlier documentation methods such as CAD. We have seen earlier in this lecture how those efficiencies can be further enhanced by having multiple different offices working together live on the cloud. A few other features that BIM 360 Design affords that you might not know about relative to the digital documentation process that are also aimed at enhancing the quality control of the models being produced are its viewer, markup tools, model compare, and automated clash detection. Not quite as robust as Navisworks, but still quite helpful, all within the same platform. BIM 360's Design's built-in viewer is pretty handy. All you need to do is double-click on the model you wish to view, and it will take you into the viewer, which is considerably faster to pan and rotate around than when in Revit. You can add section planes. It will also bring in linked models, and users can add markups and comments. BIM 360 Design also allows users to quickly assess what the difference is between different versions of the same model, and it will highlight those changes in a readily intelligible visual format for you. While not as robust as Navisworks, BIM 360 design allows for clash detection. The ability to see a plumbing pipe conflicting with a structural member can be a powerful tool and help people expeditiously resolve such conflicts. In summary, we reviewed different delivery methods, including design bid build, design build, CM at risk, IPD, and P3, and how those relate to team structures. We reviewed how to set up a work shared model on a server and on the cloud, and strategies for creating useful work sets and their relationship to work sharing. File versioning and permissions are fairly straightforward, but important to be aware of. Lastly, we reviewed a few relatively new features available in BIM 360 design that allow for enhanced collaboration and increased speed of production. While your studio projects are unlikely to utilize work shared models, I encourage everyone to contemplate how some of those topics might inform some of the design decisions you make with your studio work, and if you have not already encountered these topics while working in architecture offices, you likely will very soon. With that, this week's homework assignment is aimed at sparking some thoughts along those lines. Please refer to Blackboard for further details. I hope you enjoyed this week's lecture. Have a great week.